scientific or standard form to scientific notation, or we go from scientific notation to standard form. Remember, we always need the decimal part, and the decimal part has to be between 1 and 10, and include all the numbers that aren't zeros. And then we always have it's always multiplication, and then we always have an exponent part, and the exponent part always has a base of 10. Why? Because when we move the decimal, it's just easiest to use 10.
So technically, all you have to do is just put decimal point in between the first and second number, like on the left side.
Technically. Yes. And then count your decimal on the place, and that's your exponent. Really big numbers are going to have a positive exponent. Really small numbers are going to have a negative exponent. All right? So the last thing that we have to do before you can work on your assignment the rest of the time is look at a problem like this. So they're going to say, put the numbers in order from least to greatest. Okay? When you do this now, there's a couple different ways that you can do this. One, you can just look at the exponents, right? Because the exponents really tell you how big the number is. So for instance, like here, 3, 5, and 3, I definitely know that 1.2 times 10 to the 5th has to be my what? Biggest number. Even though that it has 1.2 right here. But it's still my biggest number because it was to the 5th power. So that means I'm moving it 5 places instead of these 2. So you really don't even have to look at it very closely until your exponents are the exact same exponent on your base of 10. So in this case, after you look at the first one and decide that obviously the 5, or the one with the 5 is your biggest one, then you got to go through and look at the other ones. So now I'm going to look at the number part of the ones that have the base of 3. Or sorry, the exponent of 3. So 4.9 or 2.3, which one's bigger? 4.9, right? So from least to greatest, we would start with 2.3 times 10 to the 3rd, then 4.9, and then 1.2. Now here's where you got to start thinking a little bit. You got to think when you get into a problem like the second one. Okay, because why? When you have, go ahead, what do you think? Why do I have to think a little bit more on this one?
Because it's going to go to the left.
It's kind of going to the opposite or goes to the left, right? Because now if it's a negative exponent, the actual bigger the number, what? The smaller the number really is. So again, that's kind of where we might want to put a little quotation mark, right? Saying the bigger number. We kind of know what we're talking about, but not really, or it's not really that case. So in this case right here, what is the biggest number that I have? 2.1 times 10 to the negative 3rd. So because it says 10 to the negative 3rd, it's still going to be a really small number, but this one is basically closest to 0 compared to this one right here, right? So 3.7 times 10 to the 8th would be my what?
Last.
Well, smallest, right? It's the smallest, even though it has the kind of biggest exponent, right? But it's the negative exponent, so it's actually. So if we did this least to greatest, which one comes first?
3.7.
The one in the middle does, right? That's actually the least. And what's the biggest? 2.1 times 10 to the negative 3rd. That makes sense?
When we write them, like in a problem or whatever, do we have to solve them?
No, I would just write them just like this. That's a good question. Everybody understand what she's asking? So you don't have to figure them out and then write them. I would just write them using scientific notation. Okay? The other thing that I did notice, let's clarify this. Any questions with any of this stuff? Again, ladies and gentlemen, don't be afraid to ask questions, because yesterday when I finally looked at your assignments that included your negative exponents, some of you had some problems with that. So make sure if you have any questions that you